look like Wayne Gretzky?
Yes.
Really?
In a good way.
Thank you.
You're the Wayne Gretzky of tennis.
Okay, so the good thing, I don't know if it's a good thing, but the difference between what we're going to do now and what we've been doing is up till this point, we've been solving equations. We are no longer solving equations. We are proving things.
Sorry, what?
Proving, okay? So it's about manipulating things to make them equal. All right? So we have learned, we've seen all these things. We've seen, we're not going to use these. Cosecant 1 over sine, secant 1 over cos, cotangent 1 over tan. All right? We've talked about those. We've used those. Those are on your sheet. What do I want to do here? We're going to skip. I don't want to do that. I want to go to here. Okay. Tangent is equal to sine over cosine. Okay. And if you want to, I'm going to do a couple of quick reasons why, because they just throw these at you and they don't show you why they are. But if you remember, well, if you look at the front page, sine is y over r, cosine is x over r. Okay? So, and tan is y over x. So I'm just going to write it over here. So if I go tan is equal to y over x, and we know that sine is equal to y over r, and cosine is equal to x over r. So you remember that? That's from when we did the circle. This would be x. Whoops. You don't have to memorize any of this bit. So if I do sine, it's opposite over hypotenuse, opposite over hypotenuse, y over r. That's where that comes from. Remember that? Yeah. Okay. So tan is y over x. So I can rewrite this as y is equal to r times sine x. All I did was multiply the r up here. I can do the same thing for this. X is equal to r cos x. Does that make sense?
Sure.
Yeah. And so if y is equal to r sine x, I can put that in there. R sine x. And x is equal to r cos x. What happens to the r's? And you get tan of x equals sine over cosine. That's where that comes from. It's not just magic, right? That's where it comes from. And then again, because cotan is 1 over tan, you can just flip them. So cotan is equal to cosine over sine. All right? You don't have to remember where they come from. You just have to know. We're going to use these ones. They're fairly common. We're going to use them quite often. But what you need to remember is tangent is sine over or cosine. Sine over cosine. Okay? Now, along those lines, these are called the Pythagorean identities because they are all squared. And if you remember, the Pythagorean formula is x squared plus y, not y to the r, plus y squared equals r squared, right? Okay. I just said that x is equal to r cos x and y is equal to r sine x. Using the same idea, I can plug them in and I will get r cos x all squared plus r sine of x. You don't need to be writing this down. I get that. Which then gives me r squared cos squared x plus r squared sine squared x is equal to r squared. Everybody agree with that? I can factor out an r squared. And then I can divide off the r squared. So I get r squared over r squared is 1, which is that identity there. Okay? So sine squared plus cos squared equals 1. And then based off of that rule and this stuff, you can generate these ones, which I'm not going to right now. Okay? But that's how they come up with these, all right? They're not just magic that they just invent and, hey, this is what happens. And this is the kind of stuff we're going to do. All right? We're going to take one equation and we're going to manipulate it using our trig functions to generate another equation. All right? Because when you get into calculus and you keep going in math, and you get really complex problems, what you want to do is you want to boil it down into something you know how to solve. Just like we did with the quadratic trig function, right? You've got this big long trig function with sine squared, sine x plus 1 or whatever. We rewrite it, you can use a substitution. We rewrite it and factor it just like we did with quadratics in grade 11. Okay? That's the whole point of this kind of stuff. All right. So let's flip the page and practice. Keep your formula sheet with you, especially for this unit, you absolutely need it. All right. So when you're doing these, right now these aren't proofs yet. We're just going to rewrite them. You have to remember how to add fractions. How do we add fractions? Common denominator. We're going to do a lot of factoring out of common terms and things like that. Okay? So and every question has multiple ways to do it. All right? So that's why we have to practice it a lot. Okay. Sine squared x over cos squared x plus 1. We need to write that as a single expression. All right. So, sorry. Okay. First way. If you have two expressions, so two terms, I should say, sorry. We have one term, which is sine squared over cos squared. The second term is plus 1. I want to add those together. How do you add things together if they're fractions? Common denominator. What's the common denominator here? Cos squared x. So I'm going to rewrite the 1 as cos squared x over cos squared x. Does everybody agree that that's cos squared divided by cos squared is still 1, right? I haven't changed anything. Why is it? Because it's anything divided by itself. Okay. You could, but then I wouldn't have a common denominator, right? So you could do that, but it's not going to help us. All right, now we have a common denominator. How do you add fractions? Just add the tops, right? So this becomes over what is sine squared plus cos squared? It's 1, right? I just showed you that on the right there. As soon as you see a trig function squared plus a trig function squared, whether it's sine and cos, or tan and secant, or cotan and cosecant, think Pythagorean identities. Or when it's combined with the number 1. So, sine squared plus cos squared, this bit, equals 1. That's off the identity sheet, so you can just sub that in. So now I've got 1 over cos squared. Is that the same as this? It is, right? Okay, so what's 1 over cos? It's secant. So what's 1 over cos squared? Secant squared. 1 over cosine is secant. So 1 over cos all squared is just secant squared. That's it. All right, that's it. We're done.
Yeah.
We boiled it down. We took this and we boiled it down to a single trig function. Okay? Now, there's another way to do it that's a bit faster. If you see it, all right? Everybody's going to look at these things slightly differently. So, the other way, as soon as you see sine over cosine, all right, even if they're squared, because you can think of it like this. Now, I don't expect you to write this step. Like, when I get to here, 1 over cos squared, I would just go, oh, that's secant squared. You don't have to write this intermediate step. This intermediate step is why it equals secant squared. Does that make sense? Mm-hmm. Okay. So, what's sine squared over cos squared? Tan squared, right? Because tan is sine over cos. So if I square it, and that means I'm squaring the whole thing. Okay? So sine squared over cos squared is tan squared. And you still have the plus 1. As soon as you see a trig function that is squared, adding or subtracting 1, think Pythagorean identities. What's 1 plus tan squared, or tan squared plus 1? Secant squared. And you're done. It's the same thing.
You're done.
All right? So that is the faster way, but you have to recognize and see it. That's what I mean is there's multiple ways to do every one. A lot of times people will see this. Do it this way if it makes sense. But if you see this quick step, you can do it really quickly. Okay? Is that okay? Yeah. Because this, tan squared plus 1, is an identity on your sheet. Okay? As soon as you get it so that it's an identity on your sheet, you can just go, well, that equals this. All right. Next one. Sine X plus Cotan X plus Cos X. So, if you have tangents or cotans in your equation or expression, you want to get rid of them. You want to write everything that you can, and I'll summarize all this, in terms of sine and cosine. Most of the time. I'm not going to say all the time, most of the time. Most of the time, you want to write everything in terms of sine and cosine. So, what's cotan in terms of sine and cosine? It's cos over sine, right? Where is it? Cotan equals cos over sine. So, I'm going to rewrite this as sine x plus cos x over sine x times cos x. All I did was rewrite the cotan as cos over sine. So now we have cos over sine times cosine. What does that equal? Cos squared. So now I've got sine x plus cos squared x over sine x. I want to write these as a single expression. So what do I need to do? You need to make a common denominator because you want to put them together. So what's the common denominator? Sine x. So that means I have to multiply this by sine x on the top and the bottom, right? That's what you're actually doing when you do a common denominator. So the top becomes Does that make sense? So now we have sine squared x over sine x plus cos squared x over cos x. You see where this is going? You have a common denominator, so you can put them together now.
saying?
What's sine squared plus cos squared? 1. What's 1 over sine x? Cosecant x. And that's it. What? All right. Okay, next one. What do you want to do? What do you want to do with the bottom one? Yes, if you see a trig function that is squared with a plus or a minus 1, go to your formula sheet and look at your Pythagorean identities. What does 1 plus tan squared equal? Secant squared. So now this becomes yeah, a and x are the same thing. Doesn't matter. So now I got 2 tan a over secant squared a. We don't want tans and secants. We want sines and cosines. So what is tan? That's sine over cosine. So I get sine of a over cos of a over what's secant? 1 over cos. So secant squared is? I'm just going to write it as 1 over cos squared. And it should be an a, not an a. Now it looks gross because we got a fraction divided by a fraction. But how do you divide fractions? Flip the bottom one and multiply, right? What do we do now? Okay. Does anything cancel? What cancels? That cancels and that cancels, right? So I'm left with 2 sine a cos a. Now later on you'll learn that that equals sine 2a, but we don't know that yet, so we'll just leave it there. That's as far as we can go right now. There's another formula we'll learn later on, but for right now you can just leave it there. We can't simplify anymore. We're all in sines and cosines. There's no fractions. There's no multiply, or there's nothing we can multiply together to simplify it down. We're done. Stop. Okay? All right. 3 cos to the 4th minus 3 sine to the 4th. If you don't know what to do, because it's just sines and cosines, so I can't do a substitution that would help us. It would make it more complicated if I did a substitution. So I can factor out a 3. We don't like that 3. All right. If you don't know what to do and you can't do anything else, try factoring. What type of factoring is that? That's a difference of squares, right? It's 2 terms separated by a minus sign. Can you square root this?
Yes.
It's cos squared, right? Can you square root this? It's sine squared. So what you get is so you end up with that. What is good about what we did right now? We're in sine and cos, but what about cos squared plus sine squared? What does that equal? 1. So that whole first bracket just goes away, right? It's just 1. So I get 3 times 1. I'll just write that. Now, what's that? It's a difference of squares again. So what does that turn into? That's just factoring. So that's it. You can't go any further. All right. Don't make the mistake that a lot of kids do when they see cos squared and the sine squared. They think even if it's subtracting that it equals 1, it's only if it's an addition. Okay? So only this simplifies 1. This is just the difference of squares you would break up like that. Huh? Can you wait? I got one more example to do. All right. Okay, second one. What do you want to do? Factor out a sine squared? Okay. We can do that. And I'm left with 1 plus cotan squared. When you see a 1 plus or minus a trig function squared, where do you look? Formula sheet under Pythagorean Identities. What's 1 plus cotan squared? Cosecant squared. Find it on your formula sheet. Make sure you can find it. What's cosecant squared? What's the answer? So it's just 1. That whole thing equals 1. There's another way to do this. Is everybody happy with that method? Does everybody understand it? I guess I should say. Okay. The other way is, what is cotan? It's cos squared over sine squared. It is 1 over tan, but we want to write it in terms of sine and cosine. So if you make the substitution on cotan, you get cos squared over sine squared. What happens to the two sine squareds on that second expression term? They're going to cancel, right? That and that are going to cancel, which leaves you with sine squared plus cos squared, which is? So that's what I mean. You can do this a multitude of different ways. All right? You just need to practice. That's the only way to get good at these things, is to practice. All right? It's a slog at first, but when you start to just get better and better at it, it actually starts to become kind of fun. All right? That's what most kids say to me anyway. I don't know. Maybe they're lying to me. Well, maybe fun is a bit of an over-exaggeration, but all right, here we go. You're gonna moan when I do it, but 5 to 16. Told you got to do a lot of practice, people.
Oh my God. Why?